Hello everyone, I am JJ. Today we are going to discuss a very important topic in mathematics, functions. Please go back and see my previous video, which is on relations. So functions is a continuation of relations. For better understanding, better to just go through that, then come back to this functions. When we talk about functions, okay, it is a type of a relation. It is a type of a relation, as I told, which we discussed in the previous video. If I consider one set A as 1, 2, 3, B as 3, 4, 5, I'm just writing some relations, which is already defined. I'm just listing out some elements. 1, 3, 2, 4, 3, 5. One relation. There will be another relation. 1, 4, 2, 4, 3, 4. Another relation. Let it be 1, 5, 2, 4. And I'll take one more. That is 1, 4, 1, 5, 2, 5, and 3, 3. A few relations I have written. This particular relation is said to be a function if, in simple words, two conditions are satisfied. First one, if every element of first set, every element of the first set, this is a relation from A to B, which I had written, is from A to B. Every element of first set should be there as first element, and it should not repeat. That is, the set A, 1, 2, 3 is there as first element. 1, 2, 3 in the ordered pair, first element is there, and it should not repeat. That is, 1, 3 is there, again 1, 5, 1, 4 should not be there. Such a relation is said to be a function. I'll repeat, every element of the first set, that is set A, should be there as first element, and it should not repeat. A relation which is satisfying these two conditions is called as a function. Or in other words, mathematically, when we explain it, we call this 3 as the image of 1. 1, comma 3 means 3 is the image of 1. 4 is the image of 2. 5 is the image of 3. So I can tell a function is a relation such that every element of set A, has one and only one image in B. Every element of set A has one and only one image in set B. So if you see the first one, every element of the set A, that is 1, 2, 3 is there as first element, and the first elements are not repeating. So first one is a function. Second one, 1 is there, 2 is there, 3 is there, and it is not repeating again. It is a function. Third one, 1 is there, 2 is there, 3 is missing. The element 3 doesn't have any image. Every element of A should have image. So this is not a function. Similarly, R4, if you see, every element of first element is there. 1 is there, 2 is there, 3 is there, but it is repeating. 1 is repeating. 1 is here as well as here. So it has more than one image. So I'll repeat the definition. Every element of set A should have one and only one image in B. Such a relation is said to be a function. To make it more understandable, what I'm going to do is just represent the particular set A and B as a arrow diagram, so that it will be easy for you to analyze it. So if I consider this two arrow diagram, first one is set A, set B. Every element of set A, that is 1, 2, 3, is having only one image. 1 is having only P, 2 is having only Q, and 3 is having only Q. So first one, I can say it is a function. What about second one? The element 2 has two images. 2 is related with P as well as with Q, which is not allowed in function. So first one, I can say it is a function. Second one is not a function because 2 is having more than one image. Similarly, if I consider this first one, every element of A is related with only one image in B. So first one, I can say it is a function. But second one, every element of A is not related. D is left out. Every element should be related. So second one is not a function. Third one, yes, it is a function. Fourth one, set A. Sorry, element A. Element A is related with two elements in B. A is having two images, which is not allowed in function. So function is a relation which satisfies the condition that every element of the first set should be having one and only one image in the second set. We'll be discussing two types of functions today. That is one-one function or injective function. And next will be onto function and surjective function or surjective function. One-to-one function. Again, a function from A to B is said to be one-to-one if different elements of set A is related with different elements in B. Different element of set A is related with different elements in B. So if you see here, first example, F is having different elements in set A. First one is your set A and second one is my set B. Is related with different elements in the second set B. So first one is one-one function, but second one, if you see the element 5 and 6 is related with the same element. Different elements in the set A is not related with the different elements. It is related with the same elements, which is not allowed in one-to-one. It is a function, but not a one-to-one function. Similarly, if you see every element of set A is related with different elements in set B. So if is a function which is one-to-one, G, H and A is related with 4, which is not allowed in one-one. So second one is not a one-one function. Similarly, when you consider onto function or surjective function is said to be, a function is said to be surjective if every element of the second set, that is set B, is an image for some element of A. Every element of the second set is an image of some element of A. That means in the second set, nothing should be left out. In the second set, nothing should be left out. For example, you see here, my first set is A and second set is considered as B. From A to B. In B, the second set, there is no elements left out. A and B is related with some element in A. So it is one onto function. Similarly, considering the second one is not onto function because C is left out. In the second set, nothing should be left out for onto. Every element of the second set should be related. These are the different types of functions. Another example is here X and Y. So here when you consider here first one element is related with only one element in the second one. So that is 1-1, but it is not onto because C is left out. Not onto means every element should be related in the second set. C is left out. Similarly, second example here, it is not 1-1 because 3 and 4 has same image here. But every element of the second set is related, so it is onto. Now, if a function is satisfying both 1-1 and onto, it is called as a bijective function. A function which satisfies both 1-1 and onto is called as bijective function. Here is the example for that. 1 to A, 2 to B, 3 to C. And so every element of the first set, it is related with different elements in B, that is 1-1. And every element of the second set is related. There is no element left out in the second set. So it is onto. It is both 1-1 and onto. Such a function is called as bijective function. I'll come up with another topic with the next video. Thank you.